This is question number 21, paper 2025, paper 2. And in this question, they've given us a triangle with height h and base x, and a rectangle with height h plus 2 and base x plus 1. Now they want us to write down an expression in terms of x for height of rectangle. So we have two equations here, while they have also given the areas of both. The area of rectangle is 11, the area of triangle is, going to write it over here, 11 centimeter square, and the area of rectangle is 39 centimeter square. So in this question, first of all, we have the area of triangle as 11 centimeter square. So we know that the area of triangle, which is 11, is equals to half times base times height. So if the area is 11, then half times base is x times height is h. Now we have one equation here and the other one is here, the rectangle one. The area of rectangle is equals to base times height. So area is 39 centimeter square, base is x plus 1 over here, and height is h plus 2. Now we have two equations here. Now we are taking out the value of h from this equation and putting it into this equation, right? Because we need to write down an expression it means we need to write down the rectangle's expression in terms of x. So here we have h, so we have to substitute this x into this h. So first we'll find the value of h here. We will write it in terms of h, so that we can substitute this over here. So it will be 11 equals to xh over 2, and it will be 22 upon x is equals to h. So h is equals to 22 upon x. Now we are going to substitute this value over here. So 39 substituting h is equals to 22 upon x in, this is equation 2. So it will be 39 x plus 1 and h is equals to 22 upon x. So 22 upon x plus 2. So it's simply this thing is the height. So they've told us to write height in terms of x. So basically now this is a new height. So the expression, we don't need to solve it further. So either the answer, there could be two answers in this. Since this is the height, so you can write h is equals to 22 upon x plus 2. Now this thing is in the terms of x. So either this could be the answer, or we'll just take this x plus 1 over here in the denominator. So it will become either this is the answer, this one is also correct, but if you take this whole expression in the denominator, it will become 39 upon x plus 1, which is equals to height. Height is 22 upon x plus 2. So the expression would be either this or this, 39 over x plus 1, right? Because this height is equals to this expression. and this height is equals to this expression. So both answers will be correct, right? In part B of this question, we need to show that 2x square minus 15x plus 22 is equals to 0. Okay, first of all we will extract this thing out of the equation of this equation actually. Basically the area, this is the area of this rectangle, and we have taken out the value of x and substituting it in this equation in the same way we did in part A. So basically this is the area's equation, area of rectangles equation. So if area is 39, base is x plus 1 here, x plus 1, and height is h plus 2 here. So we just substituted the values in the formula of area of rectangle. So now we are substituting the value of h, which is 22 upon x, into this equation. So it will become 39 equals to x plus 1 and 22 upon x, which is the value of x, and we have taken out this value in part A plus this 2. So now this equation has become like this. Now we are going to solve it further, because we have to show that this 2x square minus 15x plus 22 equals to 0. This is a quadratic equation. So let's see if we can prove it. So it will be 39 upon x plus 1 equals to 22 upon x plus 2. So we can write it as equals to, if we multiply x up and down here, the denominators will become same. So it will become, I'm going to multiply x in the top and in the denominator. So it will become 22 plus 2x upon x. Now we are going to cross multiply it. This x will be multiplied with this, and this 22 will plus 2x will be multiplied with this denominator. So it will become 39x, and if we expand it, it will become 22x plus 22 plus 2x square plus 2x. Okay, so now if I take this 39 to this side, we'll be having 0 over here. It will be 22x minus 39x plus this 2x. I'm going to write all the x's together, plus 2x square plus 22, which will be equals to this 22 minus 39 plus 2 will be minus 15x plus 2x square plus 22, and if we rearrange it, it will become 2x square minus 15x plus 22 equals to 0. So this has been proved, hence proved. So this is how we solve part B. Now in part C, by factorizing and solving 2x square minus 15x plus 22 equals to 0, find two possible heights of the triangle. So this is the quadratic equation, and this is a quadratic equation. So we will do it by breaking its middle term, and as a step 1 will be multiplying first and last coefficient, first and third coefficient. So it will become 22 times 2 is equals to 44. Now I will break its middle term. Since it is 44, so if we break it, if we make factors of 44, they will be 11 and 4. So I'm splitting this middle term into minus 11 and minus 4. So it will become 2x square minus 11x minus 4x plus 22 equals to 0. Actually, I broke this term, the middle term, minus 15x into minus 11x and minus 4x. So now I'm grouping it, step 2. Now I'm going to group it. 2x square, so I'm grouping it like that. And if I'm going to group it like this, so I have to change the sign, so that if we open it again, it will again become minus 4x plus 22. So since the minus is common here, so now in step 2 I'm going to taking, this is step 2 actually. Now step 3, I'm taking commons. So here we have x common, so it will become 2x minus 11. And if I take minus 2 common, so again it will become 2x minus 11 inside the bracket. So this is now step 4. Now I'm going to take this 2x minus 11 common, since it is common in both, so I'm taking it out of the bracket, it's common, and inside the bracket x minus 2 will be left. So now we have either 2x minus 11 equals to 0 or x minus 2 equals to 0. So we have two possible values of x. So there will be two possible heights. Find two possible heights of the triangle. So now it's 2x equals to 11 and this x equals to 2. So x is equals to either it's 11 upon 2 or x is equals to 2. So that will be equals to 5.5 and this will be equals to 2. So there are two values of x here. If you substitute these values again, the answer will be same.